Hello, this is Tom from anti-proton.com, and today I wanted to talk to you about matter and energy and what they are. You can see a little bit of energy before me right this moment. This energy is coming from the electrostatic weak force, which is sort of like the combination of the electromagnetic and the weak nuclear forces a little bit, if you like, but not exactly. Close enough. These are streams of electrons and photons being emitted as well. Let me talk to you a little bit about matter. As you probably know, atoms, like the gas floating inside of this ball, and of course the glass on the outside, and the little material that's in the inside, are made of protons, neutrons, and electrons. When you look at a drop of water, you see liquid. You know it's made of a molecule. 2 hydrogen atoms and 1 oxygen atom combined together, H2O. The H2O that you're seeing, the molecule, you know is water, and you know it has odd properties that water has. It is liquid at room temperature, and there are things that are and are not soluble in it. This is because it's, well, water. Look at the oxygen atom, the hydrogen atom, and the other hydrogen atom for a moment. You know what they're composed of, right? You may not know the exact numbers and components and whatnot, but you know that there are protons, neutrons, and electrons. You learned this probably in school. A proton is a positively charged particle. A neutron has no electrical charge. In reality, it has an electrical charge, but it's kind of zeroed out. And an electron has a negative electrical charge. So, at what point does it matter? Well, we think of matter and energy as being distinctly separate things that are interchangeable, equivalent to one another via Einstein's famous equation: energy equals mc squared, mass times the speed of light squared, if you like. But here's an interesting thing for you to think about, just a little doodly. That water is matter, right? So the protons, neutrons, and electrons, do they matter? Not exactly. An electron is energy that flows around the atom. It is a sum of electrical charge, not electrical charges, but electrical energy, the sum of a probability, if you will, of finding an electron in a particular location. You see, it doesn't orbit around the atom. It's more everywhere around the atom at the same time. If there is a full chance of finding an electron around the atom, then everywhere you look around the atom you'll see a probability, a chance, a percentile, if you like, of finding that electron. The sum of every single one of those chances, if there is an electron in there at all, will equal 1. 1 being a 100% chance of finding it. 0 equaling a 0 chance of finding it. An electron isn't so much really a thing. It's more like a flow of energy, if you like. It has various characteristics. If you were a scientist, you'd call them perhaps its quantum numbers. Its actual quantum number, that's the wave number, and it'll have a spin and an angular momentum of sorts. There's a couple numbers that are associated with it, and those 4 numbers must be unique. At least one of them out of all of them must be unique, because if you take 2 electrons and put them together and they have the exact same 4 numbers, you cannot distinguish them anymore. This is something that cannot be. It's interesting because matter should always be distinguishable, right? My point, by the way, is not to disprove the existence of matter. I'm not really proving anything. All I'm just saying is you should think about it for a minute. Matter is somewhat a little bit like the idea of cold and hot. There is such thing as hot, but really cold is kind of like the absence of heat, and sort of a relative term. In the same way, so is matter. The protons and the neutrons are the same. Protons and neutrons are made up of quarks. For the neutron, you have 2 down quarks and an up quark. These are arbitrary names, by the way. They're not indicative of anything in particular. And for the proton, you have two ups and a down. These little quarks, these triplets of quarks, they are really nothing more than quantum states, little bits of energy that are in a particular sort of configuration. Again, they can't be in the same place at the same time. And I wonder sometimes if that in itself is the only real definition of energy, or definition of matter. But then again, there are particles that can be in the same place at the same time. These are called bosons, amongst other types. A boson particle, take a photon for example, like the very light you're seeing right this moment, it can be at the same place at the same time. As many of them as you like. And nothing prevents this. In case you're curious to look it up, it's called the Pauli exclusion principle that prevents this from occurring. But pretty much what it boils down to is you can't tell them apart. Photons are not like that though. You can stick as many of them together as you wish. So is a photon matter? Or are there bosons matter? It's hard to say. The whole point of this is just to get you thinking about the fact that matter and energy aren't quite nearly so separate and distinguishable things as you were led to believe. Just a little thing to think about. Unfortunately, to truly understand this in detail, you need to usually get a little bit into quantum mechanics. But conceptually, it's easy to think about. You know, sometimes easy to think about. That's why I recommend the book by Michio Kaku called Hyperspace. Whereas I fully disagree with Michio Kaku on his reactor entombment ideas for Fukushima, I think he's otherwise a brilliant physicist. And his books are quite interesting and neat to read if you're interested in conceptual physics. And I urge you, of course, to go to your college or local university, or even your local community college, or if you're in a different country, I forgot what they're called in different countries, but the little 2-year schools, and take a physics class. You might find it interesting. But anyway, this is just a little fun diddly I'm throwing out, and it gives you a chance to hear something while you watch the plasma globe. But this has been Tom from anti-proton.com. Bye-bye.